Professor Areti. Sorry. Okay. So, welcome all the students. So this is a special courses in Tongji and focus on the topic of the digital in architecture theory and methodology and history. So today it's a great honor for us to invite Areti Markopoulou, who is actually from Barcelona, IAAC. As we all know, IAAC play a very important leader roles in the world over the past 20 years. I think Areti play a very important leader roles. She is actually the leadership of IAAC. She is right now the academic director of IAAC and also leading different group, including Advanced Architecture Group, MAA, and MACT. Areti Markopoulou is a Greek architect, researcher, and urban technologist, working at the intersection between architecture and digital technologies. She is the academic director at IAAC in Barcelona, where she also leads Advanced Architecture Group, multidisciplinary research group, exploring how design and science can positively impact and transform the present and the future of our built spaces, the way we live, and also the interaction with the environment. Her research and practice focus on redefining the architecture of cities through the ecological and the technological spectrum, combining design with biotechnologies, new materials, digital fabrication, and big data. It's also a great honor we invite Areti Markopoulou as the fellow of Digital Futures. She engaged in the Digital Futures event and gave lectures, teaching workshops over the past few years. So thanks a lot for that. And also I would like to mention she's also the chief curator of Tallinn Biennale, and that's play very interesting important leading roles of the world, and also showing she is really active and influenced the whole world. So it's a great honor to have Areti here, and the screen is yours. Thanks for coming.
Thank you, Philip, for this lovely introduction. It's always great to be back to give a talk to your group. I think the initiative that you are doing and the work that you are doing with your with the PhD seminar in the history, methodology, and theory is important for many PhD students that are working on exciting research topics. So it's really a pleasure. Good evening, everybody. Good afternoon. Good morning for me. I will start. Just give me one moment to share my screen.
Okay, we can see your screen.
Do you see my screen?
Yes, yes. Yes.
Okay. Okay, perfect. So as Philip said, I'm the academic director at the Institute for Advanced Architecture of Catalonia. Before starting with my talk, just to say that this is gonna be, let's say, a 3 lecture series that we are organizing from IAAC side. One is today by myself, then we will have 2 more in December by our faculty and experts, Alexander Jubor in robotic fabrication and David Andres Leon in computational design. So among us 3, we're trying to cover different research and contextual, let's say, work that we're developing through our research at IAAC and through our personal adventures and endeavors. So just a very small introduction to IAAC before entering into my talk. For the ones that you don't know, IAAC is based in Barcelona, is a research and education center that is focusing on developing novel solutions for cities, habitability in the future, through the use of digital technologies and through the implementation of ecological thinking. So our goal is to combine design with science in order to produce a positive impact of the built environment. And our goal is also to develop solutions that they could have a direct impact, positive impact into the society. So these are some images of our spaces. We do education through different academic programs. We do research through a series of European funded and national funded projects, and we do development, dissemination, and promotion of new ideas and practices for architecture. And maybe to say that our, let's say, core methodologies in both the pedagogical part and the research that we are developing is the multiscalar approach. So we are working on different scales in a simultaneous way, understanding that one solution to the current challenges that we are facing today cannot be only dealt with only one scale of operation, but also with a multidisciplinary approach, realizing that we need to merge together and we need to bring in the same arena different experts from different fields, including, of course, design, architecture, and construction, but as well as biology, ecology, economy, or sociology, to name just a few. And the students and the researchers in Barcelona and at IAAC, they get their hands dirty very much. So we are working and learning by doing, because one of the goals is to always have pilot projects and testing our ideas, materializing our ideas, in order to be able, in a continuous circular feedback, to inform our design and our final, let's say, solutions. We are based in Barcelona, and Barcelona is a very important urban territory for our activities. As most of you know, Barcelona is the birthplace of urbanism with Ildefonso Cerdà. The extension of the city marked what today we call urbanism. This happened in 1867. But in the contemporary panorama, we see that Barcelona becomes a protagonist in different kinds of innovation actions. In 2014, has been named for the first time the European Capital for Innovation. And for 2026, Barcelona will be the UNESCO World Capital of Architecture. So there is a lot of, let's say, interesting activity happening around design, innovation, technology, and architecture and urbanism. At IAAC, we have different kind of campuses. We have one based in Poblenou, where our main activities are taking place in research and education, but we also have a second one. Both of them are warehouses, so we are using these spaces as a space where we can really experiment, far away from that concept of the sterilized classroom. And besides the campus on the city, we also have a campus in the forest, just 25 minutes outside Barcelona, within a natural park, the Collserola Park. We have a 130-hectare property, a forest, and a house inside this forest, our Valdaura campus, where we are working on developing ideas of self-sufficiency in terms of energy, in terms of food, and in terms of producing the objects that we need with local resources. IAAC is also home to Fab Lab Barcelona. We are part of the Fab Lab network led by the Fab Foundation and the Center for Bits and Atoms at the MIT. We are coordinating all the activities related with the educational programs of the Fab Lab, such as the Fab Academy, and we are the first, let's say, Fab Lab that has been consolidated in Europe. Besides the Fab Lab, which is a fabrication laboratory that we give access to different kind of users, not only experts in design, but also citizens of different ages that they are interested to access technology and to be familiar with new ways of making. We also have labs that they are devoted to students, from robotics and digital fabrication laboratories to electronics, material labs, or AR and drone labs. And within our Valdaura campus, we extend these laboratories to include as well a green Fab Lab in which not only do we produce our objects, but we also have an area to produce food. So we have a food lab, we have a carpentry, and we are, let's say, using the nature itself in order to understand how we can take advantage most of resources. So within our educational offer, we have a series of different master programs in campus and online. I will just mention them, but you can also see them in the screen. Is the Master in Advanced Architecture, the Master in City and Technology, the Master in Design for Emergent Futures, the Master in Robotics and Advanced Construction, the Master in Advanced Ecological Buildings and Biocities, and then our online programs include the Master in Advanced Computation for Architecture and Design, as well as a series of postgraduate programs, including the postgraduate in 3D printing architecture, the postgraduate in Fab Academy, in Textile and Technology Academy, and we have a master that is taught in Spanish on the future cities, and last but not least, a new program that has emerged from this need of rethinking education, especially after the pandemic and the digital reality that enter our teaching. We have created the Master in Design for Distributed Innovation, which is a hybrid program, part of it online and part of it in campus, taking advantage our distributed network of different Fab Labs in the world. So let's say now getting into my talk, as I said, what we will be doing in this lecture series is that we're dividing in 3 different topics. The one that I would like to speak about today is the topic of scoping resources for regenerative built environments. I will use the concepts of urban mining, of resource production and building metabolism as mediums to, let's say, drive our discipline of design and building towards a paradigm of abundance versus one of scarcity. And this is something very fundamental. Now, buildings are responsible for half of the global primary material consumption, while they're accountable for almost 40% of global climate emissions, of which 40%, half of it are produced during construction. So although our contemporary practices and policies primarily focus on optimum sustainable buildings, that they are low in energy consumption, they are low in CO2 emissions during their operation, actually what we start to realize is that the biggest challenge lies on decreasing the embodied carbon of the building industry. And just to clarify some concepts and relate it with the types of carbon in buildings and the environmental impact, it is important to mention that embodied carbon is the carbon dioxide emissions that they are associated with materials and construction processes throughout the whole life cycle of a building or an infrastructure. It includes any CO2 created during the manufacturing of building materials, which means material extraction, transport to manufacturer, manufacturing. It also includes the transport of these materials to the job site and of course, the construction practices used. Put simply, embodied carbon is the carbon footprint of a building or an infrastructure project before it becomes operational. And it also refers to the CO2 that is produced maintaining the building and eventually demolishing it, transporting the waste, and of course, recycling it. So in contrast to that, to the embodied carbon, what we call the operational carbon is the carbon that comes from energy, heat, lighting, etc., during the operation of a building. And as previously mentioned, current policies and sustainable practices, they are still very much limited in reducing operational carbon. Recent data, however, from the World Green Building Council indicates that embodied carbon is becoming a larger portion of a building's overall carbon footprint. So if you're interested, you can find more detailed data in the Advancing Net Zero project, which is a report that has been produced in partnership with European Climate Foundation, the C40 cities, and Rumble. And the report focuses on the embodied carbon and emission as part of a whole life cycle approach. And through the results, in a way, it urges for systemic changes that they are needed to be done in order to achieve full decarbonization across the global building sector. And although the increasing need for building to accommodate the population growth is a fact, and it is accepted by every government, by every industry, and by every stakeholder, there are still no industry standards. There is still no building certification programs. There are still no public policies or building codes, and no widely used, transparent, publicly available methods or tools for measuring embodied carbon. So the key points, number one, to keep in mind here is that embodied carbon emissions associated with the production of building materials, construction activities, and end of life become now, which is like this orange and blue part of that diagram, become a biggest challenge to respond to compared to the operational carbon, which is during the life of the building. Now, a second significant key point to highlight in order to contextualize a bit what we will be discussing today is the impact of resource extraction that goes beyond carbon numbers. So we are gobbling up the Earth's resources at an unsustainable rate. The extraction and the processing of materials, of fuels and food contribute over 90% of biodiversity loss and water stress. And in the picture, actually, we can see the impact of sand mining at Poyang Lake in China. We know that in order to produce mortar for cement, concrete, and other building materials, the angular sand particles, which is usually found in rivers and lakes, are the most useful. And therefore, it becomes clear that our hubris for extracting materials for construction is affecting the land, is affecting the water, is affecting the agriculture, the flora and fauna around this land, as well as, of course, the urbanization and the health of people that inhabits these urbanized areas that surrounds the extraction areas. Maybe a third key point that I would like to discuss here is the material balance of the earth that is being challenged. As you can see in this diagram, the year 2020 was marked as the year when the total weight of human-made materials globally, it surpassed the weight of all life on Earth. While it is estimated that in the years to come, the growth rate of mass that will be added to the anthroposphere will increase exponentially. So this mass includes, of course, waste. And we should not forget here that the building sector is one of the world's largest waste generators. So construction and demolition waste accounts for approximately 30% of all waste generated in the EU, but also similar numbers are valid in other parts of the world. So on the one hand, we need to build more for responding to the current challenges of population growth. We actually reached 8 billion people just 10 days ago, 8 billion people in the planet. And on the other hand, we need to do so, to build more in a way that, one, embodied carbon is minimized, and two, material extraction is limited. So how do we do that, right? It is exactly in this point that the need of rethinking resources should enter our education, should enter our design culture and our policy making for the built environment. So in our current context of hypergrowth, coupled with the climate emergency, the growing rate of urbanization and the increasing social and even political awareness on the matters of the Anthropocene, the topics of resource depletion or insufficiency needs to be reframed. A proposal related to our work that we're developing at IAAC in Barcelona is to operate with an abundance mindset rather than from a place of scarcity. So this is a new paradigm that I want to introduce. It's especially relevant in the practices related to the design and the production of the built environment, since it expands the definition of resources and, of course, where resources, raw and non-raw materials can be found, and where these raw and non-raw materials can be mined. So if, as agents involved in the design, in the planning and the construction process, we could shift the attention to the anthroposphere as a source of, rather than just a destination for processed goods, then we might have the potential to disrupt linear patterns of design and enhance circularity in cities and the built environment. Through the use of some of the latest projects that we have developed at IAAC Research and Academy and through some work of my personal practice, I want to discuss two key strategies for achieving this new paradigm in design and construction. The first strategy is what we call urban mining, and the second one is the resource production in cities. To start with urban mining, this is becoming a useful concept to explore and exploit the material stock in the urban systems and to address the particularities of extraction and the use of anthropogenic resources in new production cycles. So, cities hold tons of materials that can be reused. And doing so, we can address, let's say, exploitation of scarce natural resources. So from building and demolition waste to organic, agricultural, or even textile industry waste that could become part of new construction material composites, we are actually surrounded by value. And by reframing waste products generated in urban environments or through urban activity as anthropogenic stock, the concept of urban mining helps to shift the perception of resources from a finite starting point in a linear use process towards a cyclical state of materials in a circular process. So as, of course, a key enabler of the current urban systems, as well as a beneficiary of the constant urban change rate, the construction industry is no doubt contributing a large percentage of material stock to the urban mine. So as buildings are both affected and effectors in the current linear material system, it is pertinent to ask the question of how architecture, how engineering, construction, and operations can contribute to the circular economy today. Now, current urban mining practices and policies for construction are primarily focusing on reusing construction and demolition waste by downcycling them, right? So the majority of demolition waste, for instance, is used as filler when building roadways, which prevents, basically, this downcycling prevents the further reuse or the further recycling of matter. There is also very little research on how construction and demolition waste can be reused as primary materials in new building construction. And this is due to the lack of building information on the amount, on the state, on the reuse possibility of the existing building material stock. So the current urban mining initiatives for building materials and components reuse rely mainly on expert survey and analysis of field data in conjunction with other relevant census or cadastral data sources from public building registers. So, however, I mean, like on the one hand, public building data lack key information on materials, and on the other, the need for extensive prior field research results in a process that requires high cost and sophisticated equipment, sometimes or most of the times, making it difficult to implement in low budgeted administrations or in countries where extensive public open data is not available. So developing quick, feasible, and replicable methods to create inventory of existing building stock reuse through automating the expert field audit and the inspections is a key research field that requires further exploration. Here I want to showcase two projects. Two projects that they operate in two different scales for monitoring and automating the indexing of material stock in the built environment. So the projects are complementary and they provide useful insights on the potential of the use of technologies such as artificial intelligence, computer vision, 3D scanning, and robotics for enhancing data sets on the existing building material stock. Starting with the urban scale, this is a project called Urban Mining Material Library. It has been developed with a group of students and researchers in the City and Technology at IAAC. And the project proposes an end-to-end process for an integrated web-based application which encloses and delivers cross-reference data about a city's material stock. So the process consists in combining image-based segmentation with cadastral data in a GIS database. It uses unstructured data from OpenStreetView to identify relevant patterns for making estimations of the quantity, state, and projected availability cycle of concrete, brick, stone, metal, timber, and glass in building facades. So we use computer vision, we use machine learning in order to train an algorithm that using open access images, millions of open access images, it could actually create a platform that allow us to identify what kind of materials we can find in the buildings in our cities. So by applying predictive modeling at the city scale, the algorithm is able to identify, to geolocate, and to even quantify facade materials with a present accuracy of 87% approximately, right? So the value of the process of this study does not lie in achieving a 100% accuracy. It is actually a project which value lies in the use of open and structured data as a basis, and is making it, this use of unstructured, let's say, data makes this platform a highly repeatable and expandable application. It attempts to propose a solution that crosses the boundaries of the original case study, and it can actually democratize access to data for local decision makers in different parts of the world, and more than anything in countries where open public information is less accessible. So when we are tasked with mapping different material availability at urban scale, it is immediately apparent that facade information alone suffers from a very narrow understanding of the quantities and types of material. For example, wood is not a predominant facade finishing material, but it does appear in big quantities in structural and non-structural components throughout the building. So it becomes crucial, therefore, to develop an overlapping of the image comprehension and the gun training with existing cadastral data about existing buildings, such as the year of construction, the building height, or the land use of the building, among other data. In the case, for instance, of identifying and indexing concrete buildings, we observe that building year of construction, the data about when the building has been constructed, the data about the height of the building, they can actually be better indicators of understanding, whereas the building is made out of precast concrete panels. No, the algorithm can tell us that this is made out of concrete, but whereas this is precast concrete panels or not, is something that we can extract as knowledge by overlapping the data of the specificities of the buildings. So, or even, for example, the fact that if we use the data on the percentage of glass and we use that as a filtering element, then we are able to start excluding the buildings which structure is probably built on steel frames. So this kind of, let's say, multifaceted work of using the algorithms, of using machine learning with overlapping big data on the building characteristics becomes like a very important new process on identifying the existing building material stock. An important aspect of this project, besides its technical development, lies in the creation of a web-based interface. This has been like a very clear goal for us from the very beginning, and we created a lightweight online environment that contains a variety of functionalities, including a user interface for data visualization, search boxes, media library, material chart, building material versus Google Street imaginary visualization, and of course, most importantly, data export. So the goal of the interface is to be able to be used by different stakeholders, including decision makers and of course, other urban agents, that they participate in the formulation and the planning of urban material reuse strategies. A final important aspect, this is a video, I don't know if it plays, yeah. A final important aspect to highlight is that the current study contributes to creating material databases of the entire stock of existing buildings beyond, for example, the analysis just of buildings that they are planned to be demolished. Why this is important? Well, in the field of urban policies, most of the efforts to achieve the city's goals for reducing consumption of primary materials they focus on matching demolition and construction material flows, which means they try to find a balance between yearly demolition and construction material and demand. So although such scenarios could be ideal for cities, and while recycling of demolition waste has indeed a sizable potential, the reality is that in many urban environments, including cities, for instance, like Amsterdam, that is a pioneer and highly invest in circular economy, even in cities like this, the potential falls short on achieving the policy goals that they are required for reducing primary material consumption, and that has been set forth by the 2016 Paris Agreement. So being able to acquire, therefore, building information data of the entire building stock, it becomes significant for contributing to the formulation of long-term urban policies and for planning strategies for building reuse that tackle issues of mismatch between annual demolition and construction material provision and demand. Now, the technique can be upscale and it can be applied in different territories, as I've said, where data on the built environment is scarce, and it allows, therefore, different stakeholders, such as planning experts or construction companies, to make more informed decisions towards the reuse of building and demolition waste. The technique and the results of the study can also become data sources for existing digital reused material marketplaces. I don't know if you know what this is. RMS, digital reused material marketplaces, they offer materials, upcycled materials that they are coming from demolition waste, and they offer them as potential material to be reused in new construction. So if we have a tool like this, we can even, let's say, feed this kind of digital reused material marketplaces, contributing to match offer and demand within proximity geolocations. So not only using upcycled materials, but also using them by identifying which is closer to your construction site. So this is additionally maximizing, let's say, the values of the circular and local economy. Complementary to this urban scale identification of material stock, data about the specifications of the material, including dimensions, state, properties, or even geolocation, among others, it becomes highly relevant for the potential of reuse. So not only to identify, like in the urban scale where the materials are, but also what is the state of that material? What is the exact dimension? So the creation of a parallel digital layer in order to enable the mining and to define the specific reuse of otherwise purely physical construction and demolition materials is of big importance in this context. One of the research lines of the Masters in Advanced Robotics and Construction at IAAC, it actually explores the possible use of aerial and ground robots coupled with computer vision for scanning, sorting, and digitally archiving existing material stock in buildings. This is a project that started by a group of faculty and students, and it's actually now a successful startup for the construction industry. So the research aims to employ an automated digitization method for the near end-of-life stage of a building, and it considers it as a source of high-value assets. And in order to encourage the use of valuable secondary sources of materials, and to better inform early design choices when reusing construction waste, the resulting data set is then distributed to designers and, of course, to builders. The first part of the research, it actually uses drone photos and computer vision to automatically identify building materials and components at the pre-demolition sites, And it therefore contributes to the creation of an analytical and a logistic support system that can be used to define optimum deconstruction and reuse strategies in terms of environmental and economic sustainability criteria. And the project contributes to the creation of a toolbox for quantifying, geolocating, indexing, and assessing the state of materials, and of course, their potential for reuse in existing buildings. So what is the dimension of a window or of a timber beam? What is its state? Can it be used without process? With what kind of process involved in order to come to a state that it is ready to be used for construction, etc., etc. In the tool, there are two types of data set. One related to the data scanned in the pre-demolition and a second data set related to the post-demolition, no? So what can we find there, and what is the state of it and how it can be reused? So once processing these data sets through computation, through machine learning, we are able to create categories of different building elements and materials, such as concrete blocks, wooden beams, or brick walls, and how this could be reused in another building in the future. The three important steps of this process include building inspection with aerial robots and the use of computer vision. The second one is the classification and the localization of the material stock using the machine learning algorithms. And the last, but not least, step is the geometry reconstruction based on the typology of the classification and of the localization dataset. The second section of the study, and here we can see some of possible reuses of some of the materials that have been scanned and classified from our building in Barcelona. If IAAC building will come to its end of its lifespan, what can their material become? And I mean, the second section of the study aims to transfer the previous database to as many stakeholders as possible related to the construction sector. In order to impact design and construction, it is imperative to match offer and demand, right? So a computational design tool is incorporated into existing construction software in order to offer recommendations for design adjustments from the very early design stages. The suggested system additionally offers recommendations for matching specified design components with the materials that have been previously identified as available resources. Now, while some questions related to the cost of reuse versus the cost of using new resources in construction, they are still to be answered. What it is important is to understand that such processes and techniques facilitate the implementation of the concept of material passports for buildings, which encapsulate many of the necessary criteria to support reuse. So the significance of material passports for the implementation of the circular economy in the construction sector, it calls for new policies that regulate the documentation submitted for new constructions. We need to introduce new evaluation criteria that we can set up for buildings beyond the existing required energy certificates, such as, for example, the LEED certificates. For new buildings, for instance, design should go beyond the project handover stage, and it should include strategic planning for the material sourcing, for the assembly, for the dismantling, for the reprocessing, and for storing before a new use cycle. At the same time, reality scanning and computer vision provide the opportunity to include existing building stock in such policies and to compile its material passport retroactively. Material passports are sets of data There are sets of data that they describe, define characteristics of materials in products or in buildings, and that give them value for recovery and reuse. So, of course, you know, like there is a new panorama that opens up within these concepts of circular economy, within the concepts of urban mining and reuse, because it's not only new certifications or new policies that we're calling for through this work, but it's also important to understand that there is the necessity of new urban infrastructure in the cities, such as, for example, circular hubs, where separation process and sorting of these materials could happen, because it's not like we use an existing component of a building and we directly transport it into a construction site. We need to have, you know, a new infrastructure of hubs in the city where sorting is taking place, necessary process for conditioning some of these components take place, etc. So it's very interesting, no? The fact that we start to understand not only the technical, but also the spatial impact of the implementation of circular economy in the built environment. So beyond existing building stock or demolition waste that can be indexed, it can be assessed, processes and it can be processed and it can be used for new construction. We should not underestimate the potential of identifying other urban waste streams that could become new resources for construction. There are different types of urban or agricultural waste, for instance, that they have the potential to become a new class of sustainable building composites through different processes that enhance their properties in order to match them with the building industry needs. So this is the scope of the research of the Digital Matter studio at IAAC, and it explores waste streams, experimenting with upcycling waste and how this waste could be appropriated for building components for different architectural features. So one of the case studies it researches the production of value-added building composites using agricultural waste and food processing side streams, specifically in this case, the barley straw. The use of barley straw in construction is not new, but the construction industry has neglected this resource since there are basically numerous limitations on achieving surface and geometry variations. It has limitations on scaling up without the need for secondary structures. So the specific research focuses on overcoming current limitations in surface and geometry manipulation by introducing new additives and by introducing digital manufacturing techniques. For the creation, basically the goal is to create a double curved self-standing building skin that would allow for much more complex, geometrically rich and aesthetically rich outcomes. So the composites that they are explored include a variety of performances. For instance, hydrophobicity is achieved by integrating natural resins and natural oils into the material system. This makes it basically appropriate for outdoor applications. And on the other hand, numerically controlled cutting surface subtraction is being used so that different textured surfaces could emerge, providing humidity control and, of course, aesthetic richness. So within this holistic approach of circular design, what is important in this project that we are now trying to scale up into a funded project for upcycling in construction, what is important is to understand where this waste is coming from, no? So in this case, we have been working, of course, in Barcelona with a group of students and researchers in our Digital Matter studio, and the goal was to identify waste streams that they are as close as possible to where we are. So the waste material is basically sourced by identifying the agricultural areas that they can provide barley, straw, within a maximum distance of 30 kilometers from the center of Barcelona and from where we are located. So the creation of a double-covered self-standing building elements have been tested for its implementation in building schemes, with some prototypes that allowed to understand what is feasible and what is not. But I mean, it opens up possibilities to rethink the use of barley in construction in terms of complex geometries, and it adds value to some, contemporary interesting examples of straw design proposals, such as the one we see here at Malawi School by Nudes. Now, other examples that follow similar logics and material protocols include the creation of a cork-based and mycelium composite that is using the waste stream of the active cork industry in Spain and Portugal. You might not know, but approximately half of all cork products are estimated to end up in landfills at the end of their useful life, while the other half is downcycled or used in biomass processes for clean energy generation. Taking into consideration that cork is a lightweight material with exceptional acoustic and thermal insulation properties, it is considered as an important natural alternative for architectural applications. So, as cork is an appropriate medium for mycelium growth, the prototypes combine cork waste in the form of granular cork or cork stoppers even, and mycelium to create acoustic insulation products for urban application and construction. Paper is another waste material with the potential to be upcycled and used in specific architectural application. We do recycle paper, and we know that this is a kind of a very advanced industry of recycling, but how can we use that in architecture? No, the cellulose-based composites, for instance, can be used. In this case, we have experimented on how we can create a temporary building skill components with the goal of enhancing biodiversity in cities, specifically protecting pollinators and creating pollinating corridors using the building facades by such material that could create the appropriate condition for bees or other pollinators to live there, no? To create a habitat for other species that can inhabit or co-inhabit the built environment together with humans. Of course, earth is another material that is abundant. It can be found in all construction sites and locations. And as you may know, the ones that follow our work, for many years now, we have been experimenting at IAAC on 3D printing earth-based buildings with a goal to create low-cost, negative carbon, aesthetically rich buildings, which material components can be mined and can be reused in other constructions when their lifespan is over. This is basically possible because the earth-based material we have developed in our 3D printing architecture program is enhanced with bioadditives and requires no firing. So up to 99% of the materials that they are used in our custom earth mix, they can be found locally in the soil below or around the construction, while additional materials for further construction, such as timber or bamboo, they can also be sourced locally. So a few weeks ago, we just completed a bigger prototype, the TOPA prototype of a small housing cabin. And since the earth mix requires no firing, it also means that once you build a prototype or a housing and its lifespan is over, then you can reuse the material to construct another one. Within the waste stream of urban agriculture, we can also highlight biochar. Biochar is the byproduct of the pyrolysis of organic and agricultural waste. So in principle, we are talking about a solid material that is mainly sequestrated carbon. And at IAAC, we're working with creating biochar concrete composites with the goal to minimize the embodied carbon in buildings, and with the goal to start changing our mindset towards designing buildings that they are not just zero carbon, but negative carbon, no? We have been working on different kind of architectural elements. What is very interesting with the use of biochar is the fact that it's a great fertilizer. Currently, it is used in agricultural industry as a fertilizer. So once, you know, the lifespan of a project or a building composed of this material is over, then we can separate the parts that corresponds to biochar. We can send it back to the soil, and it can fertilize it to continuously produce, for instance, agricultural projects. So this kind of building practices, they can mark a shift on the way we construct, and they can mark a shift aiming for the creation of negative carbon buildings that after their life cycle can go back to soil, becoming new nutrients, new nutrients for a new metabolism. Now, as I said in my introduction, urban mining and resource reuse from our existing building stock or from existing waste streams in cities is one of the key strategies to achieve a paradigm shift in design and construction towards abundance. Now, all agents involved in design, planning, and construction, we are called to shift our focus to the anthroposphere as a source of, not just a destination for processed goods. And the concept of urban mining is revisited to manage the material stock in urban systems and the use of anthropogenic resources in new production cycles. So from enhancing building data sets in urban and building scales, as we have seen with the examples I have shown, to introducing waste streams as new construction materials. The outcome of this work challenges the foundation of our material practices, and it presents the potential to disrupt the linear patterns of design and the linear patterns of making. Now, the second strategy, which is equally significant for implementing a paradigm of abundance versus the one of scarcity, is the resource production in cities. This is very obvious, and very direct. While urban mining expands the definition of resources and where these can be found and mined, the concept of resource production in cities highlights the importance of new forms of localization and resource production integrated in the built environment. So currently, urban policies, I mean, this is not new, urban policies and building practices, they focus on energy as the main resource production in cities and buildings. We are very much familiar with that. A series of technologies, a series of novel solutions related with renewable energy production, such as solar energy, geothermal, or aeolic, are the mainstream concepts around resource generation. And while, of course, there is no doubt that renewable energy generation should be indeed integrated as much as possible in our buildings, and we should aim for 100% self-sufficient buildings and cities energetically, the question that arises is whereas energy is the only resource that we need to produce in cities. This year, as Philippe was saying in his introduction, I have had the pleasure to co-curate the Tallinn Architecture Biennale, together with my friend and colleague, Lydia Kallipoliti. And the Biennale main theme was edible, or the architecture of metabolism. That was the title. Its core was to reimagine planetary food systems along with architecture's ability to perform metabolic processes. The main exhibition and the parallel events of the Biennale addressed the question of where our food comes from as a creative design problem. And it tackled issues of the aesthetic, cultural, and experiential qualities of spaces as productive environments throughout their full life cycles. So while most of the discussion today, especially in our disciplines of design and construction, revolves around energy, we wanted to put forward the topic of food, the resource of food, as a key resource that is not only contributing to our current environmental impact, but it is also entangled with larger ecosystemic practices. That includes biodiversity, such as flora and fauna. It includes microclimate creation. It includes health, air and soil contamination, or even multi-species alliances, among others. Actually, the Tonji University and Philippe Yuan, with a team of students, were part of the featured work with a great contribution on reimagining a new future food deal for the Chinese periphery. So how different means and technologies could allow us to rethink our territories, our buildings, our public spaces as productive places for resources such as food. Now for edible, what we did on the one hand is to explore food and architectural strategies of local production and self-sufficiency. For example, urban farming, renewable energy, or zero food mile practices that reconnect communities via food. On the other hand, we analyzed the byproducts of urban life, such as livestock, agriculture, and forest waste as resources in ways that limit material loss and explore alternative pathways. So such approach allow designers to transfer the metabolism and the experiential aptitudes that we can find in the natural world, such as concept of growth, decay, digestion, or even nutrient release, and move these aptitudes of the natural world to the domain of cities and buildings. So one of the main sections of the exhibition was the metabolic home. Each of the 7 installations in the metabolic home exhibited how processes, metabolic processes related to food, could be eventually linked to everyday domestic spaces and activities, and what would that mean in the way that we inhabit and in the way that we coexist with these systems. Food production as a process, for instance, it has been presented in a vertical robotic garden. That was a project we have produced at IAAC, and it seeks to promote a productive built environment where co-symbiosis among humans, machines, vegetables, animals, this co-symbiosis becomes fundamental for surviving. This is actually a project that is part of a series of research projects we are developing at IAAC, and they are focused on implementing nature-based solutions in buildings and public spaces with the goal to enhance productivity, to include society, and to decarbonize the built environment. So in the screen, you can see a 3D printed vertical wall that can serve as a farm for the communities. It is implemented in a public space in Barcelona. It is actually using the 3D printing and computational design to create this kind of different textures and customized components so that we can control humidity, we can allow moss to grow, we can protect different kind of edibles from sun, or to increase the exposure in the sun. We can use like typologies of design in order to create not only let's say components that can include the growth of edibles, but also components that they can become bird houses, insect hotels, etc. Some close-ups of this project, and this is the last project, very similar to the one I've shown that has been presented in the Smart City Expo just 2 weeks ago, and it explores similar logics with different, let's say, design outcomes. One of the most important things of these productive spaces in cities is that, of course, on the one hand, we're able to produce the resource of food, but with the use of the biophotovoltaic technology, we're also able to generate energy, not as much energy as a photovoltaic panel could allow us and could provide us. But in reality, what is happening is that through the photosynthetic activity of the plants, we're able to generate enough energy to self-illuminate our installations, to self-illuminate our vertical farms, or even to self-sustain the irrigation system, as well as the monitoring system through the sensors of humidity. The different textures that allow different kind of growth. We have implemented that into a public urban orchard in Barcelona, and we have done that through a co-design process with the community. So one significant part of all these processes is to understand that when you want to create an architecture that offers back to community different resources, then this community needs to be involved, because we are not discussing anymore about buildings that they require maintenance. We discuss about productive spaces that they require care. No? So we shift the notion of maintenance towards the notion of care, and we need to have communities involved in the production cycles of these productive spaces. So for the Tallinn and for representing the production of food in the metabolic home, we wanted to create a new type of farm that explores the transformation of building skins into vertical urban orchards. Edibles are grown in the building facade, and they are maintained by both inhabitants and intelligent robots. That robots can scan the levels of nutrient on the roots or the humidity in the soil. They can make sure that irrigation or nutrient feeding happens exactly where and when needed. Now, within the metabolic home, the processing of food has been presented through an interspecies kitchen by Andres Hake and the Office for Political Innovation. So using abandoned stones from a mine, the project presented a kitchen where microbes, enzymes, and byproducts of organic processes such as fermentation present a new way of recirculating nutrients. In the consumption part, we have presented a rewilded dining space produced by the Cooper Union, where consumption includes production on site and, of course, awareness of the origins of each ingredient that reaches our table. In the digestion part, that it happens in a lounge of our house, of our metabolic home, we see a series of elements, building skin elements, whose outer envelope is edible. Here, Terraform One with Mitchell Hakim and Vivian Kwan, they use puffed rice to produce building tile components that on the one hand can serve as food urgency stock, while at the same time vastly increase biodiversity by offering food, by offering food to insects, to birds, and to other small mammals. So hydration of food happens in a toilet that it endlessly recirculates and it filters water. Nutrient release, it happens in a vertical connection for harvesting. And upcycling food is presented in a garage, which is made of carbon negative voxels. Here, the team of Made of Air, led by Alison Drink, present Rock Bottom, which is an installation that becomes an open laboratory for creating new carbon negative materials for construction, that they emerge out of agricultural waste and the use of sugar. So each domestic space of this metabolic home is part of a larger domestic ecosystem, and it interacts with the other installation, the house parts, in a feedback chain of resource exchanges. Now, what becomes evident through this work is that envisioning, experimenting, and implementing architectural spaces that produce resources, that they digest their waste, that they decompose, it radically intervenes and, makes us rethink the extractive, consumptive, and contaminating logic and processes of the built environment. So within the context of our current interconnected global crisis today, the climate emergency, public health, the social inequity, the idea of a world where resources are produced locally and they are recirculated is not just a great idea, but it's a necessity. It is an urgency since it is actually vital for planetary habitability. So the metabolic home is a digestive system that receives human output and waste in its multiple forms, and it converts it to various usable forms. This portrayal of the home, it urges viewers to look at our debris, our waste of our own production processes, and the interrelated social problems that are linked to the production and the transportation of waste in a visceral way. On the one hand, we are the raw ecologists of our bodies, and the understanding that these problems are not simply statistical. They are not abstract. They are not disembodied. They cannot merely be relied only to the management of resources, but they are landed on the bodies, or on the food we eat, the water we drink, and the air we breathe. So the responsibility of how we deal with that productive architectural elements, the responsibility of expanding the notion of how ecology is being treated in the design and the construction sector becomes very fundamental. So moving beyond an understanding of metabolism as a collection of inhabitable machines, this is actually a reading that carries the heavy burden of modernism. We need to explore building and urban metabolism as patterns of energy and material generation and distribution within a multiverse, right? This reality does not tolerate the separation of humans and non-humans. Rather, it urges the assessment of a shifting web of life and death, as well as alternative forms of matter, including non-human agents. So synchronized and following, philosophies of Rossi Braidori or Timothy Morton, among others, our design discipline and culture is urged to open to the notion of non-human agents by including not only biological, but also technological and cultural others. At the same time, we are urged through our design actions to explore the potential of all natural and technological expressions in order to mitigate the contaminating and the extracting nature of our designs and protocols that are related to the production of the built environment. Now, when we bring resource production back in architecture and cities, we're able to understand better and participate more actively in the interdependencies among resources, production, consumption, distribution processes, human bodies, and even health. And if we have a look, for example, at the current model of production, distribution, and consumption in cities, a model that is brought to us by the Industrial Revolution, we realize that we live dependent on an outdated production and consumption model. So we extract resources that are not abundant, we transport them in outdated factories in order to massively produce far away from where we need to consume. Then we again transport these projects to cities, we consume, we finally produce waste. And not only do we produce a huge amount of waste, but we are additionally again transporting our waste far from where they are produced. So this linear system of take, transport, make, use, and dispose is a system that is not sustainable neither in economical nor in ecological or social terms. So food uncertainty, the impact of the pandemic on industrial production and distribution of services and goods, the Russian war against Ukraine and the energy crisis related to this, or even events such as the blockage of Suez Canal in March 2021 that seized global transportation of goods, creating a major impact on the international economy. All these facts, they are realities that foreground the urgency for a united reflection on the fragility of our production and distribution processes, on the significance of the geolocation and mediums of such processes, meaning the significance and the acknowledgement of where do things are being produced and how they reach their final destination, how they are consumed. So we are urged for a united reflection as well on our exaggerated lifestyles that lead to ceaseless growth and endless mobility. And finally, a united reflection on our accountability for how we occupy our planet. The aim of my contribution today, and I'm summing up, is to invite you all to reflect upon the paradigm of abundance versus the one of scarcity. You know, one fundamental mistake of the mainstream idea of sustainability, or at least the way society perceives it, is the aspect that we need to compromise our needs and desires. We are asked to consume less, to build less, to generate less emissions, to move less, and so on and so forth. But at the same time, the global systems in place, as we have already seen, they operate in a totally different mindset, in a mindset of centralization, separation between waste and valuable matter, extractive approaches, and heavy carbonized production processes. So we need to ask more from architecture. We need to ask more from our design practices. We need to ask more from how technology can serve design, to ask more on how our byproducts are reused, to ask and do more on how and where our resources are generated in buildings and cities, to ask and implement more design processes that are based on the possibility of architecture to reuse existing resources and building stock, and eventually to implement new forms of localization and a new paradigm that operates with an abundance mindset rather than from a place of scarcity. So we do need to consider our urban and built environment as potential mines of novel resources, as potential producers of resources, and work around the policies, the technologies, and the multidisciplinary teams that they are required for this paradigm implementation. Because such paradigm can provide actionable areas for designers and decision makers, and aim for a regenerative world that is able to continuously recirculate the resources required to sustain itself. Just closing, I would like to recommend two relevant readings, which are two books I co-authored and edited, and include some of the work and thoughts I shared here today with you. So thank you for following my thoughts, and I'm looking forward to any possible question and to our discussion.
Thank you. Thank you so much for the mind-blowing lecture. It was wonderful materials, and I think especially the concept and the vision Areti gave us as a one planet. We should be thinking on the design from a philosophical perspective, and why we make construction, how we can live more harmony with the world, with the environment. And especially the topic urban mining is a way to rethinking on the urban material library, how to recreate urban life and living style, and including the food, including the everything surrounding us could be redesigned. And the designers actually can contribute, can actually engage through different methodology and design tools to do something more meaningful and based on the new philosophy. I think it's a mind-blowing lecture, which gave us a totally new definition of what is design. as IAAC, from our early impression, because around 15 years ago, you gave a lot advanced technology, including the early 3D printing methodology, which is leading the whole world rethinking on how we can construct different installation, different buildings, pavilions. And we can see a lot of very interesting projects from IAAC. And today, I think IAAC is leading by Areti is totally going to a very interesting direction, and including the Biennale, the vision, the topic is quite attract us. Rethinking on the planetary life, and after 2020, the post COVID-19 era, actually the people should rethinking on the carbon issue, and also the Anthropocene stage of the whole Earth. Actually, as you mentioned, we should not only think about the zero carbon strategy, but also the negative carbon, which is totally could base on rethinking on the urban mining. So that is quite clear. If your the digital matter, as you mentioned, your workshop, I think is fantastic in your studio. Create as a kind of creative process, including the material, including the new material performance, including the toolbox, including the hardwares. So it's all combined in following the new vision. So that is quite fantastic to me. So we have actually a lot of questions. I would say
maybe one comment.
Yeah.
Thank you for the nice words, and thank you for always being interested in the work that we are developing. Mm-hmm. I think I want to mention two things. The first one is that the fact that we are leading academies and we are involved in education, it makes we are at a moment that we need to realize that we have huge responsibilities towards how we educate the future change makers of our discipline. We need to be able to, go a step away from these enclosed laboratories where we research and we just talk among like a very limited amount of people. We need to be able to develop work that can have immediate and big impact in the industry and the society. And I think this is like a moment that we cannot allow any more delays, no? We have lots of knowledge, we have lots of technologies in our hands, we have extraordinary intellectual power and strength. So I think it's a matter of really trying to bring together different minds and hands to make things happen. And I think that in your case, you're also a very relevant reference, not only with the work that you're doing in the school, but also with your practice, like trying to understand how new buildings could really introduce new ways of making, new materials, new ways of connecting with the local craft or the communities. This becomes fundamental issues for the challenges of today. So I think we need to realize that there is a huge responsibility on our shoulders, and the more we distribute that responsibility by creating communities of co-working, the better. And I also wanted to say that a year ago I have you have invited me again for a talk. And I think it was in June 2021. And there is another talk that can be found online. And I think it is very, very complementary to today's one. And it's maybe also a bit more digging into specific projects of the work that we're doing and how this respond to the challenges. So I also invite the students, if they haven't seen that they can also go through that.
Yeah. Thank you so much. I 100% agree on Areti's special vision. rethinking on the creativity, and also it's very urgent for all the designers and the whole planet rethinking on the ways how we should live in together with the planet. Actually, we will upload all these lectures, including last time we invite Areti in June 21st. That's already uploaded to the YouTube and Bilibili. If the students here you are interested in Areti's lecture, you are also welcome to visit our website, Digital Future website, and to watch the special lecture. And also we have two questions from the floor. Usja, would you like to put forward your question to Areti?
Okay. Thank you for the lecture. May I ask a question? In this project, different materials from different places were identified as offering the possibility to rebuild another building in another place by using the construction waste. I think maybe these used materials need some treatment before being used. For the same material, do we treat these used material differently depending on their current state? For example, in terms of size or degree of damage. If the treatments are different, is it possible or necessary to identify their different states in the process of identification of for the convenience of the following process? Okay, this is my question. Thank you.
Yeah. Thank you for your question. Totally, that is the case when we are trying to identify existing building material stock, when what is necessary is to start from the bigger identification of that, as we did with the urban mining material library, and then zoom in to understanding the state, the dimensions, the possibility of reuse of certain components. So the project I've shown on the scanning of the building components in the interior is actually exactly focused on that, on how to index, on how to categorize, on how to assess the different states of these components. In some cases, some components cannot be used. For example, maybe some wooden beams are already too deteriorated that they cannot be used as structural elements. But then, you know, we are able to, through this process, to also understand what kind of reuse we can give to these components. So maybe a wooden beam that is deteriorated can be used for flooring or for cladding, no? Another component of a brick wall could be reused exactly as it is for a new building facade, no? So it is very important to identify and to index the state of the components, the exact properties, the possibilities of reuse, and what kind of post-process is needed. Sometimes it is needed, and this is why I mentioned that the circular hubs as a physical infrastructure is something that is necessary, is something that is already happening in some pioneer cities, but it needs to be, let's say, extrapolated and implemented in more cities in the world. They are hubs where different kind of sorting, but also processes happen.
Good.
Oh, thank you for answering.
Okay, thank you. We have another question from Yang. Would you like to ask him the question? Are you here? Maybe I can read the question for him. Urban mining brings me to the Prize Prize winner, Wang Shu. He actually frequently used the waste building materials in his design, dealing with the waste of materials. Is his style of design inspire your team? That's an interesting question.
Thank you. We are inspired by every let's say initiative that is trying to rethink our material practice, and we're inspired by any initiative that might come from different fields, not only architecture and design, but it can also come from, the world of synthetic biology, for instance, or the world of ecologists in relation to, biodiversity aspects. We are inspired by every work is trying to rethink our material practice and is trying to break this kind of linear pattern of extracting, using, consuming, and disposing.
Okay, thank you. We find another question from Liu Haning. Would you like to ask your question? Liu Haning, are you here?
Hello, Professor. Thank you for the wonderful lecture. I have a question for you. In the lecture, you shared a lot of pavilions built with sustainable materials, which are environmentally friendly. But I see they are all small in size. And recently, Kishokuma's Nakagin Capsule Tower in Japan, which is an iconic building of the metabolism, was demolished. And it seems that the concept of metabolism is hardly guiding us to build complex buildings of large size. And I want to ask you, how do you see the future of the concept of metabolism in large size buildings? Thank you.
Yeah, thank you. That's a very, very relevant and appropriate question. Thank you for that. First of all, to say that the way that we need to approach metabolism today should be adding to what has been considered as metabolism in the Japanese movement, like the capsule tower in Japan and the metabolism movement in Japan was actually trying to land principles of metabolism in a very metaphorical way, or let's say extracting the processes of metabolism to the way that the building is operating without any thinking on the materiality. So metabolism today is adding into that concept, the aspect of materiality. So it's not anymore about the idea of adaptation of, creating structures that they can expand, they can adapt in geometry, they can, mutate in terms of its physiological aspect. But we are discussing about literally involving metabolism in buildings. So literally buildings that they are being grown, literally buildings that they can decompose, buildings that they can literally, let's say, become an important biological function within a system that is not only including humans, but it includes the built environment, it includes the other species that surround us. So this is a big challenge, I think. It is, of course, a big challenge on the scaling up, but it is a big challenge on the scaling up only if we continue thinking the way that we build in the same way that we think today. So the big mistake is trying to think that the new buildings should be the same as they are today, but with other materials. That's not the case. That's not the case. We're not discussing about building a 50 plant skyscraper made out of, organic waste. What we are discussing about is to rethink the way that we build, is to rethink whereas we need this kind of structure, or how we need to place them in our urban environments, and how the materialities and the metabolic processes could help us change the way of what a building is. So there is a kind of a much more radical or thinking out of the box necessity in terms of our design culture that we need to make.
Yes, great. I think what Areti mentioned, the metabolism is a new metabolism, which is totally based on the, I think, new horizon about the relationship between the architecture and the human body. and architecture and the environment. This is totally new to rethinking on how we can harmony living on this planet. So I think it's really meaningful, really inspiring, and give us new enlightenment, actually open a new window to the discipline. So thank you so much, Areti. Thank you again.
Thank you, everybody, for listening.
Yeah, thank you so much. I think we should keep in touch in the future. Especially, I was invited to curate another exhibition next year in Shanghai, city art season, which is also the other site located in the outdoors in the park and also in the suburban area. So looking forward, maybe we can invite you to participate to the special event in the near future. So let's keep in touch.
That sounds very interesting. Looking forward to discuss more about this.
Let's keep in touch.
Thank you for the invite, and thank you for everybody for participating and for the discussion.
Yeah, thank you so much for the lecture and the wonderful time with us. Thank you so much. Bye-bye.
Bye, thank you.